chapter 6, rational expressions and equations. So rational expressions, just so you know, a rational number is a number that can be expressed as a ratio of a numerator over a denominator. So it's something that we turn into a fraction, right? So when we talk about rational expressions here, what it's going to have is we're going to have numerators and denominators, and they'll have like polynomials in their numerator and polynomials in their denominator. So they might have monomials or binomials or quadratics in their numerator and same within their denominator, okay? And we're going to be doing a lot of factoring of things, so which we've already been doing. Okay, so let's just see. The next one is working. Okay, here we go. So rational expression, here's your first definition. If you want to write it down, if you don't, that's fine. It's an algebraic fraction with a numerator and a denominator that are polynomials. So examples are 1 over x, m over m plus 1, y squared minus 1 over y squared plus 2y plus 1. And then the other one they have as an example is x squared minus 4, which doesn't look like it has a numerator and a denominator, does, because you could actually express this as x squared minus 4 over 1. So this is still a rational expression, even though it may not look like it has those two pieces. You can make it look like it has those two pieces. Okay, and then one thing I want to go over right away is you are not allowed to do this. What pen does it say? It's kind of slow. You are not allowed to cross off those m's. Okay? You're also not allowed to cross off these y squareds. Okay? So those things are not allowed, and I want you to keep that in mind. The only way you can cross things off like that, where you can cross off some in the numerator and some in the denominator, is if they all have coefficients that can be reduced by the same thing. So let's say that this had like a 4, a 2, and a 6. I can reduce all of those by dividing each one by 2, and this expression could become 2m over m plus 3. But that's all I can do. So I can reduce all the coefficients, so that's one thing I can do, or I can factor it and cross them off. So this guy right here, and we'll practice this within the examples, y squared minus 1 is actually y plus 1 with a y minus 1, because it's difference of squares. And the bottom, if you factored it, it's a y plus 1 with another y plus 1. And since now all you have is multiplying in between, you are allowed to cross off, as long as everything's fully factored, because technically you've taken out the adding and subtracting that's in between, it's now within a term, you can cross those off that way. Okay? But you can't just straight up cross off variables. It either needs to be coefficients get reduced, or it has to be factored first before you cross it off. Okay? Let's take a look at the second definition here, which is non-permissible values. Okay? So non-permissible values, I think that's a new term. Is that a new term for you guys? Non-permissible values? It's basically the values that aren't allowed. So when you did your restrictions for chapter 5, you set out which items are non-permissible because you said which ones were allowed. So then we would know all the others are not allowed. Okay? So in this case, when we have these, it's any value for a variable that makes the expression undefined. And remember, it's undefined if it has a denominator of 0. This is a no. You're not allowed to have a 0 in the denominator. Okay? But this is okay. You can have a 0 in the numerator. That is allowed. Okay? 0 in the numerator is allowed because 0 divided by any number is 0. Okay? But a 0 in the denominator is not allowed because any number divided by 0 gives you an error on your calculator, or it's called undefined. Okay? So in a rational expression, a value that results in a denominator of 0 would be a non-permissible value. So when you look at this guy right here, we have an x plus 2 getting divided by an x minus 3. You must exclude the value for which x minus 3 equals 0. So basically my denominator can't be equal to 0. Well, what would make that equal to 0 is if x was 3. So if this was an expression for some rule or whatever, you are allowed to put in any x value you want and you will get out an answer except for 3. You cannot put in x is equal to 3. Okay? Now there's a couple of ways to do this. You can state your non-permissible values are, and you could say x equals 3. Okay? Or some people don't say non-permissible values. They just say, hey, x cannot equal 3. So either way is fine. So you either use the word non-permissible, and then you can put equal, or you just say not equal to, and that's okay. Alright? If you use non-permissive values, you put not equal to, I'm not going to dock you for a double negative, because you do know what we mean